let's get started. Before I start, as Bill said, I work as a senior consultant for Cluster, and we provide basically an Cluster managed platform, and I work as a consultant where we help our clients having any issues. Okay, I just Rushi, can everyone hear fine? I just want to make sure because I got a few comments that we can't hear properly. That's all right. So you can confirm that. Okay, perfect. Okay. So yeah, here is my detail. I mean, please feel free to reach me out after the webinar if you have any questions about Kubernetes, Kafka, Elasticsearch, Cassandra, anything. I will be more than happy to answer or help. Also, there is my LinkedIn profile as well. Feel free to add me as well, and we can, just if you have any questions. So today's agenda is we're going to talk about introduction to Kubernetes, log monitoring in Kubernetes and challenges, introduction to Fluent Bit and EFK architecture, and a brief introduction about Opendistro for Elasticsearch. So what is Opendistro for Elasticsearch? And then we will talk, we will deploy Opendistro for Elasticsearch live on the Amazon Kubernetes cluster. Then I will deploy a Fluent Bit, which is basically is going to use to enrich those logs from the Kubernetes. And then we deploy Kafka as well, which is basically another open source platform. I'm not going to talk about Kafka. If you're interested, I will share the screen where you can. I've given some more talks on how about Kafka as well, so feel free to reach that, see that as well. But I will deploy that, and we can then see how we can enrich those or look those logs in our Elasticsearch. So yeah. So before we start our talk, let's discuss what containers are and how they are different from VMs, because this is very important. Kubernetes works on containers. So what are the VMs? As the name itself suggests, a virtual machine represents a logical software abstraction of a machine that can be used by end user as a physical machine. The virtualization can be done at a platform level, thereby emulating a complete operating system at the process level, restricting it to a single process. Unlike VMs, containers do not handle a bundle full operating system. So they only have libraries and settings required to make software work as needed. This makes for efficient, lightweight, self-contained systems and guarantee that software will always run the same less regarding of where they are deployed. So, we've had traditional deployments where we would just use bare physical server, then we move into virtual VMs where we had hypervisors, which will be then subdivided into the VMs, and then came the containers, because containers then can then be deployed on one physical machine on one software operating system, but then on the application level. And this is where container comes in. And so let's talk about containers as we talked about already. Let's talk about microservices. So first of all, what are the microservices and how they are related to containers in fact? So microservice architecture that split your application into multiple services that perform fine-grained functions are as part of your application. Instead of a big monolithic application, you can subdivide your application into smaller microservices which can perform certain type of tasks, such as, talk about an e-commerce side. You could have an e-commerce side where you would have ordering system, transactional system, and other services. One idea would be to create a big monolithic application and put everything there, or subdivide into the microservices, which can then be deployed as part to do a same job which a monolithic application will do. Now, rise of microservices also make it easy because use of containers as well, so that we can use containers because it's quite easy to deploy, and that can be deployed into can be packaged and then deployed very quickly. Now, the advantage for containers and services is fine, but now the when drawbacks comes in when you go and deploy those containers onto physical machines, in then you still have to deploy them under a cluster, and just to make sure that your services are up all the time, or you can bring those microservices come up and down. And that's where you physically go and deploy those. If you were to deploy as a clusters or as a number of machines, you need to go and deploy manually, and that can be very challenging. And this is where we use, a tool which is to use to orchestrate all those containers. In fact, so Kubernetes itself, that comes the Kubernetes. Hopefully everyone knows about Kubernetes because obviously we're joining it, but just so that if you are not aware about much of Kubernetes, just want to give a brief introduction about Kubernetes. So Kubernetes is an open source container orchestration program system. That's basically for automating application deployment, scaling, and management. So you can basically deploy containers. It manages those containers yourself. That was originally built by Google, and it was then open sourced in Google. Kubernetes originates from the word Greek, meaning a helms or a pilot, basically, that a Kubernetes means. Now, what are the key features for Kubernetes? That provides, as I said, it comes from Google. It provides auto scaling, which means that you can deploy containers and auto scale them as you like it. So you can say, okay, I want to deploy a certain microservice or certain application 10 times, and then on certain physical machines, the rest is taken care by Kubernetes. So you don't have to worry about that, all those things where you will have to manually log into every physical machine or a VM to go and deploy those services. And so self-healing infrastructure, storage orchestration, which means that you can, expand your storage as you require. So for example, if you deployed some application and you say, okay, I need now 10 GB and tomorrow you need 20 GB or 30 GB, instead of physically moving that, if you are on cloud, all you can do is use the Kubernetes API to call the storage of cloud provider and get more storage as you require. And rolling updates and CI/CDs and other stuff. And then it provides load balancing and routing all itself. So once you deploy it, you don't worry about how the routing within that Kubernetes cluster work. It's all taken care by the Kubernetes itself. And namespacing is to deploy them into different services. So for example, you could have some, you wanted to separate them, your container application or microservices based on specific criteria. You can do that through Kubernetes itself. So let's start it, what the Kubernetes cluster or Kubernetes looks like. So Kubernetes is configured on one or more nodes. So node is a physical or a virtual machine on which the Kubernetes is installed. Node is a worker machine, and this is on which the Kubernetes is basically, you can go and deploy that. And it was also known as minion in past. So there might be, hear this interchangeably about minions or worker nodes. But what if, let's say in this example, as you can see, we've installed microservices, we've installed Kafka on as a containers. But what if you needed to deploy more? I mean, what if your application goes down or physical node goes down? You need obviously something called a cluster of those physical nodes. So in Kubernetes, you can use something called cluster concept, which is a set of physical nodes, worker nodes, that can then hold, you can go and deploy those containers on top of them, which we'll talk about what the containers are. In the sense of they're not containers, they're pod. This way, even if one node fails, you will have your application still accessible from other nodes. Moreover, having multiple nodes help you sharing a load as well. So which means that you run an application, you say, okay, I want to deploy on 2 machines. Later, you say, okay, usage has increased, so I want to deploy on 3rd machine. So if you have extra machines, you can easily deploy them as well. So now we have a cluster, but who is responsible for managing that cluster? where the information about that member of a cluster is stored. And how are the nodes monitored? So these are all the questions comes, because obviously previously we saw there was only a cluster, and that's something that's all those questions, like how do we manage that? How do we say, okay, I want 5 copies of same specific application to be deployed on all those worker nodes? Who does that? And this is where the master comes in. So master is another node in Kubernetes which is installed and is configured, and it watches for all the nodes and is responsible for actual orchestration of those containers on those worker nodes. So as you can see in this diagram, we've got these different containers being deployed. We basically, as administrators, go and ask our master nodes saying that we want a certain application, for example, a Kafka, deployed 3 times into all those worker nodes. And these are all taken care by a master node. We won't be going too much detail at this moment, but that's just a concept from a master perspective. Now, as we discussed, Kubernetes is our ultimate goal is to deploy application in containers. Okay. However, Kubernetes does not deploy containers directly on worker nodes. So if I go back a little bit, this was a diagram. These were specifically, I put those small icons as a container, but Kubernetes does not deploy them directly those containers. Instead, containers are encapsulated into something called object called pods. Okay. So for example, a pod is a single instance of an application. So for example, you've got a MySQL service, which is running a one container. Could have a Kafka service, which running 2 containers, or Redis service, which running 3 containers, or could have a microservice running as a separate service with 2 containers. But itself, it's one pod. So pod is the smallest object that we create in Kubernetes. Very important concept to take it from here. Now, I know I've just scratched the surface because of the time. I just don't want to go too much detail into Kubernetes, but let's now talk about, I hope the idea was there just to give an idea about this Kubernetes concept. And now we move into Kubernetes logging, for which we basically have this. So log monitoring in Kubernetes is vastly different than logging on the traditional server or virtual machine, mainly due to how it manages its applications. So in Kubernetes, there are many moving pieces together to the bottom of an issue. A large distribution system is very challenging. For example, when an app dies on a virtual machine, logs are still available until you delete them. Okay. On the other hand, in Kubernetes, when a pod are removed or crash or deleted or scheduled, they lose, all the state or the log information itself. So to give you an example, for example, this Kafka pod itself, if it's running here, there is a possibility it could go down, and we could say, because we deployed with the 3 cluster, but we said, no, 3 were too much. We could ask one of the node, we can ask master node to reduce the number of nodes or increase the number of nodes. And that can be challenging when it comes to monitoring those logs itself, because those logs, as the pods are destroyed, those logs are disappeared. So, and also, other challenge is, as compared to traditional environment, Kubernetes clusters tends to have significantly more servers. So think about microservices, think about containers or pods, and think about ability to handle and easily expand your services. And that's where you tend to have a large amount of servers, and that can be a significant problem for operational teams to manage those logs itself. So as we talk about microservices, they are common, and these microservices itself could also have built-in containers, could have their own logging system, works together, and we want to make sure that we can gather that And those microservices work independently, but itself, it works for one specific application. And we want to make sure that that application we are monitoring is able to monitor it properly. And that's where all those challenges come in. The question comes, how do we monitor this pod which is going up and down? Or how do we monitor this microservices which will be distributed into different physical nodes, but doing the same thing? And these are all the things comes into mind when you think about logging and monitoring of Kubernetes. Now, Kubernetes itself, you can use kubectl, which is fine. You can use the logs for that, but that's not can be challenging itself to use it. So here's what is. Let's talk about logging context now in Kubernetes. That's something is a concept. Because logging context is very relevant here in Kubernetes, mostly because if you have one log message, that log message was generated, for example, here from some container, as I said, but this container come from a specific pod, which is there, right? So we had pod containers, and that container could sit into a specific namespace, so that we can have different namespaces for different services, okay? And then could have different labels and annotations. So that becomes very challenging. As this information allows you to give context, because at the end, if you have a distributed application and you generate the label and annotation, you would like to correlate all those information back, right? Because you don't want to say, for example, when you put it into your Elasticsearch or in database, that give me a log from a specific container from this physical node. No, you want to have a whole picture of that application, how it's performing all together from the logs perspective. And that's where you have it's a context. So in Kubernetes, you need to try to get all this, as a whole context to solve the logging. So for example, you need a container name, container ID, pod name, pod ID, namespace, which namespaces they're coming from, nodes, what physical nodes they are on worker nodes they are installed, what labels and annotation, and so on. Okay. So the file system contains, that's something is important to say. So we got containers, we got pods, we got container. On pod itself, container is a Docker. It's just a Docker which is running inside the Kubernetes. So file system contains that what is really one of the from the local position, like you can get pod, the pod name, namespace, and the container information. So that all this is related to itself, like a container which is producing that log. So I'm talking about, if I go back, these are all this information come from a file system perspective. But then on top, you have other information when I talk about a pod ID, the container ID, the worker nodes, and things like that. And that's where you use that information comes from separately from a API server or master server we talked about, right? So from a cluster perspective, API server or master node in the Kubernetes also have some information like, pod ID, label, and annotation and things like that. So container information, pod ID. How do you correlate it? You need some kind of a log processor so that it can contain all that information and put it as a log process that log, okay? And what that log processor is today, which we are going to talk about, is Fluent Bit, okay? There are other log processes like FileBeat, or Beats is another one, or Fluent D, which is from the same project from Fluent Bit, but I'll talk about a little bit more about that. So you need a log processor who can correlate all those information, the container, the API, combined together for that specific log and push that into some sort of other tools. And we'll talk about it. And this is where the Fluent D comes. So what is Fluent D? A Fluent D is an open source multi-platform log processor and forwarder that is written in C, okay? It's very lightweight, and obviously for Kubernetes, you need lightweight because it needs to deploy as a daemon. It needs to be deployed in all physical nodes and collect lots of information and if you have a heavy log processor, can be consuming. You don't want to spend too much of your memory on a log processor itself. It takes around 650 kilobytes, but also it has a pluggable architecture and also provides built-in security. Okay, what is basically a difference between a Fluent D and Fluent Bit? You will hear about these quite often, but just to elaborate it, Fluent B was originally started as a tool for capturing logs from different places. It's a huge project, has 1,000 different plugins. You can get everything, but one of the drawback is it's very heavy. So it uses 40 MB of traffic, 40 MB of memory to deploy it, right? And it's written also in C and Ruby. But however, on the other hand, Fluent Bit is very lightweight, as I said. It's written on C. It's only consumes 650 kilobyte of storage, has around 70 plugins, enough from a Kubernetes perspective. So now Kubernetes monitoring or log monitoring, Fluent Bit is a go-to product now, or open source product from a perspective of what to monitor, okay? So let's talk a little bit about what Fluent Bit components are. Sorry, I'm going very fast because I've got a big demo to do as well. So I just don't want to spend too much time on the theoretical part. I just want to make sure that you see physically how it works. So that's why I'll go very quickly. But if you have any questions later, just ask me. So input plugins. So let's talk about how the thing works. So when you deploy Fluent Bit, it starts with an input. What is input? You can have different input messages types. So plugins you can use to get your log information. You can have input like logs being generated by TCP, by Docker container, a log file, and a tail, a CPU and memory. All those are input plugins. And there is a huge list of it. You can click on this link and it will give you all the input plugins which are available for Fluent Bit to read that data. So input plugins gather information from different sources. Some of them are just like data from log file, other can be gathered metrics information and other operating system and so on. Okay. Next comes the parser. So dealing with raw string or unstructured data is constant pain, and having the structured data is highly desirable. Logs are not always structured, and you need to make sure, and mostly they come in some of them services which comes as a JSON format. It can be easy to make them like a key value pair where you can search against some certain types of logs. So for example, Apache log does have information about where users are logging into, which country and things like that, and that's a one log line. But what if you just pass that into a key value pair? So you say, okay, what was the country they coming for? That's where the parser come in. So Fluent Bit support different parser, and here's a list of those parsers like JSON, regex, decoder, and log format. You can go more detail about that, but yes, the parsers are available. Then comes the filters. Basically, a filter in production is give you a control of what you want, and that's very important in log processor, right? So filtering is implemented through a plugin, which is also, there are lots of filters available. This specific configuration we're going to deploy today as well, and just want to make you clear that this filter is going to use a Kubernetes filter, which says that when there is a Kubernetes start value for a Kubernetes, make sure you use this filter and do all the certain things to process these logs. So right, so filter is implemented through plugins, and each plugin could be used to match, exclude, enrich your logs with specific metadata information, as you can see in this example as well. Okay. Then comes the buffer. So there are possibilities where sometime it does provide buffering mechanism. So when you say, for example, a file system is you're pushing some logs and it's not able to handle the amount of logs, that's where you can use buffer to store them on a local disk as well. But this is basically then comes the routing concept. So all those information comes in, input, parser, and everything. This is part of, and then comes the routing. So routing has two concepts. Whenever the logs are hit here on input side. You can tag them. Either you can do it manually using certain logic and say, okay, I want this input type. And then on the routing side, you can basically, when it's just about to send to the output side, you can match those tags basically. So and that's where the information come in. And it's very important that the tags is also added on the start of it, because if it does not have the tag information, it Fluent Bit will delete those logs. And then comes the output. Output is where you send those logs to. So Fluent Bit support NATs, Kafka. There's a lot of other. The list is here. I've included that. Elasticsearch, where we're going to use it. So it allows you that whatever information have come from all this within that Fluent Bit itself and route it over. So you could send to multiple outputs as well based on that. So it's very powerful. So you could send Elasticsearch, Kafka, and some other tools at one go, the same message. So let's now talk about EFK. That's a very important. So we talked about, you used to talk about ELK, but mostly now things are becoming very common to use EFK. And what EFK stands for is Elasticsearch, Fluent Bit, and Kibana. So we have this log processor, right? But we want to send somewhere that logs. And that's where this EFK architecture comes in. So you get all those logs from your Kubernetes machines and logs, push that into something look like this architecture. This is something I've just taken as a standard diagram. It could be different as with different services. So for example, you could get a Fluent Bit to gather all those logs from a Kubernetes cluster, and you could send one to a Fluent D, which is a separate server it could be running, which can then push into Elasticsearch cluster, and then we can enrich that in Kibana. Or other tool could be you deploy your Elasticsearch cluster in the same Kubernetes cluster and send those logs. And this is what we are going to do today. So we're going to deploy an Elasticsearch cluster and a Fluent Bit within the same cluster, and then we do the enrichment of those logs. What is Elasticsearch? Elasticsearch is an open source distributed platform, which basically written in Lucene. As you can see in diagram, it does support different types of messages or data. So you can enrich, you can send log messages, metrics, documents, and it's purely a search engine, but it's now used widely for monitoring, log monitoring, and things like that. Okay. If you haven't heard about that, we do have lots of webinars that we've done. We're talking about Elasticsearch itself. Those Elasticsearch logs information can then be sent to Kibana. Now, today we're particularly talking about something called Opendistro for Elasticsearch. So if you haven't heard about Opendistro for Elasticsearch, Opendistro for Elasticsearch is being on a very high level. Opendistro is an Apache 2 license. It's backed by AWS or Amazon. Opendistro comes with additional capabilities, right? Enterprise grade thing. So if you get a standard Elasticsearch thing without having any enterprise subscription from other different companies, this specific flavor of Elasticsearch comes out of box. It does provide security, alerting, and the performance analyzer and so on. There are many other features which are purely free of cost. You don't have to get any sort of subscription to get it. Just download it. They are out of box. Security is one of the important features of Elasticsearch. Lots of companies do require that, and that's where Opendistro for Elasticsearch does provide out of box, i.e. LDAP, SSL, auditing, and all those things. And on the top, you get alerting, and then comes the SQL and so on. I won't be talking too much. We just want to give a bit of information about that. Once those logs and everything comes from Fluent Bit, hit to Elasticsearch, and then comes the Kibana, which we can then use it to visualize those logs. Okay. So this is what is all about for today's presentation. I'm going to do a live demo, and just want to understand what are, if you have any questions before we go for a demo. So what is the, so I've got a question now. What is the major difference between ELK and EFK to use in Kubernetes observability? Okay. EFK is a bit older approach where ELK is more aimed to APM. Okay, depends now what is your specific requirements are. Now ELK, I wouldn't say EFK is a bit old approach. Well, EFK originally was Elasticsearch, Fluent D, and Kibana, but now things are changing towards more EFK, which is Elasticsearch, Fluent Bit, and Kibana. What ELK is Elasticsearch, Logstash, and Kibana. And to be honest, we don't deploy Logstash in Kubernetes now. It's too heavy. Similar to Fluent Bit, it can be very heavy to deploy. What we deploy is something called beats, and that's something from Elastic Stack, which is called file beat and what we call metric beats. Okay, right? Yes, that's correct. So file beat and metric beats, you can deploy them, but bear in mind they don't do out of box APM monitoring. They do the same as what we call enriching those logs, which will do that as well. And I do have a plan to talk about, not in this webinar, but in future, how we can use ELK as well. So yes, some companies prefer like ELK model, whereas some use EFK, which is Elasticsearch and Fluent Bit, because Fluent Bit itself is pure open source as well, and lots of companies moving away there towards that, because they provide also security and things like that. So Opendistro support both EFK and ELK. That's correct. And today I'm going to deploy Opendistro and Fluent Bit, and you'll see how we'll enrich those logs. If you don't have any questions, can I move into demo? Or if you have any questions, that's fine, because I think I have half an hour, but I just want to make sure, and there's a lot of exciting things to show. Okay, no questions. Perfect. Let me now move into share my screen, which I will share a screen of this one. Move this here. Just 1 second. Okay, 1 second. I'll share my screen. So new share, I'm going to do a desktop or full share. Okay, I now have, hopefully you can see all, see the terminal. Yeah, just please just tell me yes. Okay, perfect. So I am going to show, I have a AWS account. I mean, I've got an AWS EFK cluster. So on the AWS, I've created one cluster, which is basically called EFK. It's a Kubernetes cluster. It's up and running. Nothing in there exactly, just built it before that so that we could save some time. So I am going to now show that how it looks like. So Kubernetes get pods tells you how many pods we have it. Currently, we don't have any pod into it. Okay. If I do Kubernetes get logs, good nodes, it will tell how many nodes. These are the physical worker nodes I have it. So currently it's a clean cluster, nothing is there, and we're going to deploy, and these are physical nodes. Okay. Now I'm going to basically start deploying first the Kubernetes, which we call the Opendistro for Elasticsearch. Okay. So in order to go that, just so that before I can do is Opendistro for Elasticsearch has its own page. Search for Opendistro for Elasticsearch, and in order to use the deployment, I am using this method of Helm deployment just to make it things very quick. I mean, I had the plan to do a longer one, but I just want to make sure that we can quickly deploy that. You can follow the same if you need to, but you can watch my videos again, how I deployed it, just in case if you want to deploy again. So what we're going to do is basically first I am going to go and deploy Elasticsearch for this one. Just more than a second. Cluster. So got this done. So I am on the, I have two folders. This is called resource folder where I am. This is my local device. I am going to go inside that folder and creating, so I have just ls. So there are these three folders, okay? As per the instructions, we have to clone what we call, if you can look at here, we need to clone git repo, like this repo. I'm going to do that. I'm not going to show this again page, but just to show that we just go and git clone this. And then when you clone it, it basically downloads a folder called Opendistro for build. Okay. If I now go and cd into Opendistro for build, all we have to do is, as per the instruction, you need to go to Opendistro for Opendistro -build, and then you need to go to Helm, and then the folder is called Opendistro-es. That's the folder. Once you downloaded that from a GitHub, just ls that, it will give you the values.yaml file. So just to let you know, just to show you how the YAML file look like, I am going to show that here. So if I go and look that on the, once again, if I do a refresher of that, Opendistro, Helm, and Opendistro, and then values.yaml file. So yeah, value.yaml file looks like this, okay? It gives you by default how many nodes you want to run. So we are going to deploy Kibana. As we talk about, Kibana is for visualization, and we're saying we just want one port. It's going to use the specific port. Out of box, it does provide security, but obviously what it does is, as a development, we are just using a standard what we call certificate, but it's very important that you have to have those certificates. Now, what we're going to do is basically go a little bit down and then say what type of Elasticsearch cluster we want to deploy. So Elasticsearch, okay, and it has different type of nodes. So Elasticsearch have master nodes. So we say by default it comes with 3 nodes. We want to have it comes with 1 node. We want to deploy 3 nodes of master node. If you're aware about the architecture, as good, but look for nodes type if you're not aware. So Elasticsearch does come up with different type of nodes. Okay, so in this case, we're saying we need 3 nodes for master nodes. Then it has data node, which holds the data for the Elasticsearch cluster. We say we want 3 of them. And we're going to say there are client node. This is kind of like a load balancer. So it's Elasticsearch cluster, which looks like with length. So we say we want 2 of those. So I'll just go and save that file, and I'm gonna go and deploy that with the Helm package. Okay, just do Helm package dot this one. It successfully go and deploy. So you can use now. We get this package downloaded, and then you deploy the Helm install. That basically installs now that Opendistro using that Helm package itself. All those values which we have provided, okay, it is go and deployed it. Now, if I click on, so if I clear that and click on, if I say watch kubectl get pods, you'll see all those pods now initiating it. Okay, so you got Opendistro for, so we said we wanted 2 client nodes. Okay, we wanted 1 Kibana nodes, 1 data node, and 1 master node. Bear in mind, as we discussed, these are all pods. Okay, what are pods? The pods have certain container within them. So for example, if you look here, that says that this specific application has 1 container in it, and that container is a Elasticsearch, right? Okay, and also Elasticsearch. So it's, what we did was watch mean that continuously look for those pods to come up. Okay, and if you look now here, we are initiating a master node, the 3rd master node, because we wanted 3 replicas. So what would have done is basically, it would have taken this pod. Now, this is all is the magic of Kubernetes. If we were to deploy Elasticsearch cluster on a physical VM or a Docker container, we had to physically go on all these 3 nodes, because bear in mind, we have a 3 node cluster in Kubernetes, right? These are the 3 nodes cluster. It has taken this information from a master node and has distributed all those containers into those physical nodes without us doing anything extra. All taken care. It knows where these nodes, pods should be residing and things like that. Okay. Now this is coming up. Cluster is up now. I can see everything is up and running. Okay. So I clear that, and what I can say is that if I do kubectl get pods again, okay, I can now say, okay, give me Kibana. This is the Kibana name, and if I say kubectl get logs, no, kubectl logs, and then name of that, Kibana does take a little bit time to go and deploy it. So saying it's taking some time to deploy it. These are the logs you're getting. So the only way normally, if you don't deploy Fluent Bit or File Bit, Elasticsearch and everything, is the only way is to use this command, kubectl logs and this one. And these logs disappear as the logs, the pods go away. And that's where you need tools like, Fluent Bit and other stuff. So currently now, I see that the pod is still trying to initiate it. Okay. What we can do is basically, in the meanwhile, is there is a command called, because if you see kubectl on the other window, get pods, we can use something called port forwarding. In order to access something, we use a command called port forward, and then we tell /deployment, and the name of Kibana. What it's trying to do is, on my local machine, I'm trying to say is connect to this Kubernetes cluster and treat that I'm connecting locally, because obviously Kubernetes is sitting in cloud, and I want to go and connect that to my Kibana host. Okay. Somehow it did not like it, and what was that? kubectl forwarding, and then we need to give a port number as well, because obviously Kibana is running on 5601. Okay, it does not like it. 1 second. Did I put the right Kibana name? This is the one. Okay, 1 second. Okay, let's put this here. Oh, okay, sorry. It's a service. We need to get on the queue. So if you do kubectl get service, not the pod itself, that gives you a name of the service you want to connect it. So we do have a Kibana service that we need to connect to. So now we can go and get that deployment up and running. We got and forward, and now I will go and open. If I do localhost, obviously Kibana runs on port 5601, and that's going to give me the Kibana interface itself. And then out of box, we get username and password to deploy it. Default username is admin. You just log in basically and explore your own, and that basically gives you the Kibana itself. Now we need to get quick because I need to deploy more stuff as well. So if you look at it, it comes with the security and everything and all the things. We're not going to talk this today, but you can do it. Just one command you can look at it in Kibana as well is if you want to see how's your Elasticsearch cluster look like, you do the same thing. Get there's a get underscore cat / node. This is one of the REST API commands you can do from there, and you get all those cluster running. I hope you're aware about Elasticsearch. I mean, if you're not, I think it will be good to know how the Elasticsearch works and things like that. I think there are some webinars where I do talk about Elasticsearch. Please do look at them if you look at them. That's why I'm just. So that's basically our Elasticsearch cluster is up and running. Now, one important thing from Kubernetes perspective is basically because Elasticsearch comes with Opendistro specifically comes with what we call certificates, like and that certificate has to be provided in Fluent Bit in order to get to connect to the Elasticsearch cluster. So what we're going to do is basically going to come out of this. Right. Okay. So I will create one folder called certificate, make mtdr certificate, go inside that folder. If I do ls, now I've got one folder called Opendistro, which we downloaded. Certificates folder, if I go and certificate, this is very important if you're deploying, you're connecting Kubernetes cluster Fluent Bit with your Opendistro, because otherwise it will not work. That's a very important step. If you do kubectl get pods, you need to know, because Fluent Bit will be connecting to Elastic client nodes or any of those nodes to push the data. We want to exit into one of these clients and get what we call the certificates, which are added as part of it. I do have a plan to create some videos. I mean, I'm planning to open a YouTube channel where I will explain everything, how to create your own certificates and all those things. Due to the time, I can't go in much detail, but what I'm trying to do is, from my machine, I'm exiting into one of those pod and trying to give me what is inside that folder. Obviously, every container runs its own. It's like its own operating system, even though they share the same physical operating system, but these specific pods have their own structure and everything. So in here, I'm saying exit into this pod and then look at the file here, the folder here. And this is the folder where Opendistro for Elasticsearch hosts their file. And we are interested in this root.ca. This is the CA, which is basically is file which need to be passed on Fluent Bit while we are connecting to the Elasticsearch. Okay, so the way we do it basically is by a command where if I do here, instead of ls, I will do cat, go to that file, and I'm looking for a root CA, and then what I'm trying to say is do like this. So this file, we say cat that and put that into my local folder, which I just created now. If I do that, If I do ls, now I should have this root file. If I do cat on this one, I should have that certificate being copied from the cloud into my local machine. Now, next step is very important, is to put this into a secret. So there is a concept in Kubernetes called secrets. So if I do get secrets, secrets are where you can store some information like your certificate as we downloaded as a secret. So you don't have to put it manually somewhere. So there are different secrets being created automatically. I'm going to create one secret now using this file with the command. So the command is kubectl create secret. It's a generic type, root ca, the name of the secret, from file, and the file name is the one which we talked about, this one. Okay. If I create this one, you should see another secret being created, and that's a secret which is being created. If I go and describe about the secret, so you can use the command kubectl describe secret and the name of the secret which we have created. You can see that secret holds this file, and this is the file which is on our local folder as well, right? It has been pushed into this folder, and we'll be using this into our now the next step, we've got Elasticsearch cluster up and running. We need now Fluent Bit to start gathering all those logs. Okay. Fluent Bit is basically can be deployed using okay, so if you need to go and deploy the Fluent Bit, there is a manual as well using, I use this here. If you log in here, on the Fluent Bit side, there is these specific commands which we're going to do it. You have to download the service account, the role binding, and then itself deploy something called daemon set. So the concept in Kubernetes about daemon set is basically, instead of deploying as a pod, which only deploys on a specific node, when you tell I want to deploy as a daemon set, it makes sure that it automatically deploys on all physical worker nodes, which means it can then go and get those logs. So Fluent Bit will be deployed as a daemon set. Okay. Now, to do that, first of all, what we do is we need to deploy as a service account. First, to deploy the Fluent Bit, we deploy as a service account. So we need to see if we have any other service account. For the sake of simplicity, I'm using the default namespace, but you can use some different as well. So if you do, like I'm going to just cat into resource folder, and there is a Fluent Bit folder, and there is a file called resource.yaml, because this is the config I need to deploy. All it's doing is creating a service account with the name of Fluent Bit and deploying on that on the service. So this is basically, so I cat into that device to that file, and now I've just click on this service account, and then we can start looking at this. So I think we are just running out of the time, so I'll be very quick. So now we've added the Fluent Bit service account. Next step is you need to basically go and deploy something called role map. What role maps are is basically says that we will have access to watch list, and these are something you can do it based on. This is basically because we want Fluent Bit to be able to read, watch, and list all those services. So these are kind of actions which can be done by the Fluent Bit itself. So I'm going to go and deploy that as well. Then I'm going to do and deploy a role binding. So the concept for role binding is basically is that we created this role map. We created this. So we created the service account. We created this role map which can do some stuff, and that is then role binded into something called a role binding, and that role binding can then be used in daemon set so that they know what they can do. So I go and deploy that as well. Now we got the cluster role binding is done. That next important concept is to deploy. This is a standard one, but the next important concept to understand in deploying Fluent Bit is something called config maps. And I can just quickly show how the config maps are look like. I'll just open this up. Here's a config map. This config map looks like this, where we say, and these are config maps which are passed to Kubernetes daemon set. Okay, a config map is all the config we want it to do for Fluent Bit to do. For example, we talked about input filter. So in this, we're saying that we want input filter of Kubernetes to get the logs based on any tag which has a Kubernetes.start. Remember that tag we were talking about? That's important on the output side. Okay. Then comes the filter. Filter tells that I want to be able to enrich, or I want to be able to just get this specific logs out of it. Okay. And that's a filter section, right? Input, filter, output. Output is saying that I need to be able to send that to Elasticsearch, match anything which is coming from input. Here we could put kube.star as well, but I said do anything. Then we're providing the host name and the password, and then log stash format, because obviously this format is uses like a base like on the log stash. And then the very important bit, remember that we use this root CA, we copied that from the Elasticsearch. This is where we're saying that use this file when you're connecting to Elasticsearch. And now these host and other information should be in something called, so this config map itself is passed into something called daemon set. And daemon set is basically, it's like a pod, as I said, but it's deployed on every physical node to make sure it gets all the logs from every service. And just to elaborate a little bit, the host name we passed in the config map is basically getting this information about, so the config map will get information, the name of the service, which is Elasticsearch service we want to connect, what port we want to connect, what username and password. And the other important thing, if you compare that to, the standard, this is the standard daemon set on their website I downloaded from, but one extra step I added was this one. So we are saying that volume mount a search folder, and that search folder will have an information about that, where it gets this information. So it puts everything into a search folder, whatever is in this secret name, and this is the secret name we created earlier. So it goes and get that and push those information into that. So quickly, we will now go and deploy these configurations. So all I'm going to do now is going to deploy those config maps, and hopefully we will have a Fluent Bit config map created. And then it's the same kubectl create file, and the same for the daemon set as well. So I'm going to say, okay, go and deploy the daemon set as well. Okay, so the command to see if the daemon set has been successfully rolled out, you see kubectl rollout status daemon set. And hopefully, if we have deployed, it will say successfully deployed and rolled out. If you now do kubectl get pods, you will see we've created 3 daemon sets. Why 3? Because we have 3 physical nodes in this Kubernetes cluster. So if I see Kubernetes worker nodes, get nodes, so you got 3. So if we add a 4th one, somehow later, it will add automatically another one. Okay. So we got now Elasticsearch cluster, and we said go and get our logs from there. Okay. Now we go back to Kibana, and hopefully we will see that we start to get a logs. And if everything was according to the thing, we should be able to see. So in Kibana, in order to get the log information, you create something called index pattern, because Kibana will not realize what the logs is. So we can see that the logs have come in from a log stash.star. Okay. what we're trying to say is this was the log stash format. Even this is a bit confusing. You can have your own name as well if you need to, but this basically, because we said in our config map we wanted a log stash format, that's fine. But this could be any name. It could be any index name and things like that. So if I click on that, I say I want to do it based on the timestamp. I think we have. Okay, and here you go, boom. So we got now all those logs up and running and coming in with Opendistro, with all those metadata automatically being passed, put it into a key value pairs and information being created. Now the advantage is that now once it's in there, I can start looking these logs. For example, I have a log here, all those logs, and I can tell Elasticsearch, all these logs that are coming and running. If I click on that and say, okay, give me anything related to Kibana now, or maybe a pod name, right? Label, these are all the labels and everything. So, okay, I say, okay, I want any information only from Kibana. You press that button in Elastic Kibana, you can only see now logs related to only Kibana, right? You can also do the other way. So you can say, okay, I don't want that. I don't want anything which is not Kibana. So you can start looking those logs automatically. Okay, it's very interesting and very powerful from that perspective. You can just get those logs. And now this is basically what is now everything coming in. Then we can create something called visualizations as well on top of that. So for example, I say, okay, I want to create some visualization. I want to say, give me all the values of pie chart. I want to create it based on some specific, you know, I want to split this, create a term aggregation based on some node names, right? Pod names, for example. Click on this, and can all of a sudden see that I can now have node name of what nodes names are written in our cluster. You can say that and do that. Sorry, Bill, how long I can go extra if possible, because I need you to deploy.
Actually, we probably have a couple minutes, maybe
Okay.
5 minutes at the most. Sorry,
Okay.
we have another event incoming, so we have to stop. Probably 4 to 5 minutes.
Okay, that's fine. Thank you, Bill.
Okay, great, thanks.
Yeah, so I think, okay, I will quickly do it. I don't want to explain anything. I'll try to deploy Kibana quickly, you know, Kafka, but it's basically, yeah, this is something if you are interested in deploying Kafka as well, there's another, I've got also, we've got like, if you go to our Insta cluster website as well on the virtual events, you should be able to look how you can deploy Kafka as well on Kubernetes. So running Kafka easy way on Kubernetes. So I'm going to deploy that quickly, and just to show how quickly as we deploy Kafka, how quickly that can be, you can start getting it. So just give me 2 seconds only, and then I clear that up. Less resource file, I do it. What we call, let's see if we have it here. And that, not going to. Okay, so I'm going to deploy a Kibana cluster quickly and say, okay, I'm using a method, something called operators, which is another way other than Helm charts. As I said, if you're interested in learning how you can deploy Kibana or anything using operator, that is also very useful to see that as well. So if you go and see watch, it's going to deploy Zookeeper and Kafka. But what we are interested in, if we install this now, in a traditional way, we had to create a separate logging method and everything and things like that. Kubernetes, everything changes with Fluent Bit and everything. Now, if I come back here and I say, okay, give me anything now of Zookeeper, you can see, you will see all of a sudden, we will start to get a lot more logs coming in from a Zookeeper and other stuff. And here you go, boom. So we created a Zookeeper cluster with all those information, Kafka, and these logs have started appearing as we go. I will stop it here. I wish I had more time. I would have explained that. But yes, without doing anything, without us specifically setting the Kibana, the Kafka log settings, we got already the logs coming because Fluent Bit is doing its magic as well. And obviously Elasticsearch as well. Sorry, I think I'll have to stop it. I wish I could continue, but yeah.
Yeah, thanks. Unfortunately, yeah, we have other events coming in a few minutes, but I do want to have a few minutes to have some questions and discussions if you have. I see some questions in the chat and also in the Q&A. Is those one already been covered? Maybe you can just quickly go through them.
Yes, yeah, let me go through this. So what is the major that's done? So Opendistro does support, yes, so Opendistro for Elasticsearch, as you can see, I've just deployed, and we can get and connect Fluent Bit and get those logs into Elasticsearch. What is other question is, can we retrieve history in ELK and Kubernetes? Yes, as you can see, you can go back to the history. Now I'm showing last 15 minutes. Once you deploy, you can go to last hour, years, depends on how much data you want to store, and that will store there as well. Yeah, I think if there is not any other questions, then I think we're fine.
Is there any other questions? We have probably one last questions, if any. Last question goes 1. Last question goes 2.
So
3.
logs will be persisting forever regardless of Kibana is down. Yes, so there is one more question came in. Logs will be persisted if the Kibana is down. Yes, because we have deployed that Elasticsearch cluster into our cluster, and data is normally stored on a data nodes in Elasticsearch clusters. And yes, you're right. Even if Kibana goes down, you can still get it.
There's another one in the chat say, do we have to install Ubuntu for Kubernetes?
No, you don't have to, because this is done. It's all taken care. This is the magic doing that on cloud. So I was using AWS. So you can literally go and just deploy that Kubernetes cluster. It provides everything out of box in that sense. So you don't have